Students, welcome back to my channel. In this we'll see what is exercise 7.3 chapter 7 permutations and combinations. So previous video we did exercise 7.2. Now we'll be doing 7.3. So here the sixth problem we have done in the previous video from 1 to 5. Now we'll be doing the sixth problem. The sixth problem, what is it? We'll just read. Find n if n minus 1 P3 is to n P4 is equal to 1 is to 9. So in the solution part, what do we have here? We are having that. Now we know what is NPR equal to. NPR is equal to n factorial by n minus r factorial. Therefore here you can write this as n minus 1 P3 is equal to, you can write it as n minus 1 factorial divided by n minus 1 minus 3 factorial, which is equal to n minus 1 factorial by n minus 4 factorial. And next we are having what is np4 is equal to n factorial divided by n minus 4 factorial. So this can be written as, here you can write this as n minus 1 P3 is to np4 is equal to 1 is to 9 is given to us. n minus 1 P3 divided by np4 is equal to 1 is to 9 or 1 by 9. So therefore n minus 1 P3 into 9 is equal to np4 into 1. So therefore you are getting this as n minus 1 factorial divided by n minus, we have seen that this is equal to n minus 1 factorial by n minus 4 factorial into 9, which is equal to n factorial by n minus 4 factorial. So these two will get cancelled over here. So therefore you are getting here n minus 1 factorial into 9 is equal to, this can be written as n into n minus 1 factorial. So this n minus 1, n minus 1 will get cancelled. So n is equal to 9 is the answer for this seventh one. In the seventh one, how do we do this? We'll see solution for this. So find r if, first one 5 PR is equal to 2 into 6 PR minus 1, isn't it? So now we know the formula NPR is equal to n factorial by n minus r factorial. So first we'll write what is 5 PR is equal to 2 into 6 PR minus 1, means it can be written as 5 factorial by 5 minus r factorial is equal to 2 into, you can write this as 6 factorial divided by 6 minus of r minus of 1 factorial. So which is equal to 5 factorial by 5 minus r factorial is equal to 2 into, this can be written as 6 into 5 factorial divided by 7 minus r factorial. So now this can be written as, here you know that this will get cancelled. So therefore here 1 minus 5 minus r factorial is equal to 2 into 6 divided by, you can write this as 7 minus r into 6 minus r into 5 minus r factorial. Now this and this will get cancelled. So you are having 7 minus r into 6 minus r is equal to 12. So therefore this will become 6 sevens are 42 minus 6r minus 7r plus r square is equal to 12. So therefore 42 minus 13r plus r square is equal to 12. So if you bring it this way, you will get r square minus 13r minus plus 42 minus 12 is 30. So now for this you have to find out what are the factors. It's a quadratic equations. So now we'll get for r, two values we'll get. So what are those values which satisfy this r? We'll see. R square minus 10r minus 3r plus 30 is equal to 0. R minus 10 minus 3 into r minus 10 is equal to 0, or r minus 3 into r minus 10 is equal to 0. So r minus 3 is equal to 0 or r minus 10 is equal to 0. So r is equal to 3 or r is equal to 10. So therefore you're getting two values of 3 or 10. Now second one is 5pr is equal to 6pr minus 1. So second one is 5pr is equal to 6pr minus 1. So now how do we write this? We know that npr is equal to n factorial by n minus r factorial. So therefore 5pr is equal to 6pr minus 1 means you can write it as 5 factorial divided by 5 minus r factorial is equal to 6 factorial by 6 minus of r minus of 1 factorial. So therefore this is 5 factorial by 5 minus r factorial is equal to 6 into 5 factorial by, here you will be getting it as 6 plus 1, so 7 minus r factorial. So now here you can write this as, you can cancel out this. So 1 by 5 minus r factorial is equal to 6 divided by 7 minus r into 6 minus r into 5 minus r factorial. So this and this will get cancelled. So it is 7 minus r into 6 minus r is equal to 6. So therefore this is equal to 42 minus 6r minus 7r plus r square, which is equal to 6. So 42 minus 13r plus r square is equal to 6. So r square minus 13r plus 42 minus 6 is equal to 0. So r square minus 13r plus 36, which is equal to 0. So now here we have to find out factors in such a way that we'll get here. So we can take factors of 36 as 9 into 4. So therefore r square minus 9r minus 4r plus 36 is equal to 0. R into r minus 9 minus 4 into r minus 9, which is equal to 0. So r minus 4 into r minus 9 is equal to 0. R minus 4 is equal to 0. R minus 9 is equal to 0. So r is equal to 4 or r is equal to 9. So therefore you are getting these are the answers. The previous one we got 3 and 10. Here we are getting it as 4 and 9. So now going into what is the 8th problem. How many words with or without meaning can be formed using all the letters of the word equation, using each letter exactly once? So now having equation is having how many letters? E, Q, U, A, T, I, O, N. There is no repetition in this letter. There is no repetition of letters in this word, right? So now here total number of letters is equal to how much? Total letters is equal to 8. So what is the permutation of 8 different objects which we can form over here? We'll see. Of 8 different words taken 8 at a time. So now we are having here n is also equal to 8, r is equal to 8. So how many can be formed over here? You can see. So now here what is it? NPR formula is equal to n factorial divided by n minus r factorial, which is 8p8 can be written as 8 factorial by 8 minus 8 factorial, which is equal to 8 factorial by 0 factorial, which is equal to 0 factorial is equal to 1. So therefore 8 factorial is equal to, so how many numbers can be written over here? It is 1 into 2 into 3 into 4 into 5 into 6 into 7 into 8. So this is equal to our 8 factorial. So therefore if you multiply all these numbers, How we can write? 6 fours are 24, 24 into 30 into 56, which is equal to, so you're getting 40320 is the number of words with or without meaning form. What is the ninth question? We'll see how many words with or without meaning can be made from the letters of the word Monday, assuming that no letter is repeated. If 4 letters are used at a time, all letters are used at a time, all letters are used, but the first letter is a vowel. So now here solution, how do we do this? Now you are having here how many, what is the word which we are using? It is Monday. So how many letters is this Monday containing? So total letters, that is equal to, that is n will take, it is 6. So now what is the first condition which having? 4 letters used are used at a time. So now here r is equal to 4 means NPR we can use, which is equal to n factorial by n minus r factorial. So here 6p4 is equal to 6 factorial by 6 minus 4 factorial, which is equal to 6 factorial by 2 factorial, which is 6 into 5 into 4 into 3 into 2 factorial by 2 factorial. So these will 30 into 12, 364 letters are used at a time. Okay, so now what is the second? All letters are used at a time. So all letters are used at a time. Here n is equal to 6 and r is also equal to 6. So therefore our NPR is equal to n factorial by n minus r factorial. So 6p6 is equal to 6 factorial by 6 minus 6 factorial, which is equal to 6 factorial by 0 factorial. 0 factorial is equal to 1. So 6 factorial, 1 into 2 into 3 into 4 into 5 into 6. So 2 3s are 6, 6 4s are 24 into 30. So 720 is the number of possible letters are used at a time. From this we can be formed. Now all letters are used, but the first letter is a vowel. So now all letters are used, but first letter should be a vowel. So now we're actually using multiplication principle. It will become easy. Okay, so multiplication principle, what is it? We'll see. So now here can form a letter of 6 letter word. So what is a 6 letter word from Monday? The first one, you know what are the vowels? A, E, I, O, U. So here how many vowels are there? 1 and 2 vowels are there. That is A and O are there. So the first word 1, 2, 3, 4, 5, 6. So this first one should be done only in 2 ways, because there are only 2 vowels over here. So therefore 2. Now this, in this first one, suppose if O is filled over here, what are the remains for the second letter? Second alphabet letter can be filled in how many ways? 1, 2, 3, 4, 5. This can be done in 5 ways. Then next, because here this is the first letter which is gone, second letter is gone from this 6 letter word. So how many ways are there more? 4. Now if 3 letters are gone from a 6 one, you will be left with 3, then with 2, then with 1. So therefore 2 into 5 into 4 into 3 into 2 into 1, which is equal to 1040 into 6, which is equal to 240 ways is the. So therefore first, again once again I will just tell you all letters are used, but the first letter should be a vowel. So the first letter, whichever is a vowel over here, if you're having here again 1, 2, 3, 4, 5, 6, isn't it? The first letter should be vowel, means it should be either a O or A. So this can be done in two ways. Now the next way, because O or A is filled, either O is filled means the remaining are 5. So it can be done in 5 ways. Then if even this, suppose we are using M. So the remaining, these 4, what are there? They can be done in 4 ways. It can be written in 4 ways. N, D, A, Y, any one of them can be written. Now you are using N also. The remaining 3 can be written in 3 ways. Now if you are using D also, the remaining 2 can be written in 2 ways. Then the remaining 1 can be written in 1 way. So in this way you will be writing this, and you will get it is 240 ways it can be written. Now next, going into the 10th one. In how many of the distinct permutations of the letters in Mississippi do the 4 I's not come together? So now here Mississippi is given. So how many letters are repeated how many times, we'll just see over here. So here the letter M is repeated, letters repeated, we'll just write down over here, and number of times. So first you take letters repeated, suppose M is given, so it is repeated only number of times is 1. Now I is repeated how many times? 1, 2, 3, 4. 4 times it is repeated. Then S is repeated how many times? It's repeated again 4 times. Then you having P. P is written 2 times. So here these are the number of times each letter is repeated. Now he is telling that here I, the letter I should be in how many of the distinct permutations of the letters in Mississippi do the 4 I's do not come together. So these 4 I's should not come together. So now how do we arrange this? How to write this? How many words can be formed using this I in distinct places? All the 4 I's, that is 4 I's not come together. So here total number of letters is how much? Total number of letters in Mississippi. That is N is equal to total 11 are there. You can count and see. So therefore you now have that. Now here, now what is R value? So here R is also 11. Why? Because he is telling that all the I's should not be put together. So therefore here times you can put these 2 S's in this place, and this 2 S's you can put in this place. It becomes the same word. In the same way, this I can be in this place, this I can be put in this place, this I can be put. So whatever is repeated, we divide by the number of permutations formed over here. So here you are having N is equal to 11, R is equal to 11, means you are having 11p11 divided by whatever are the repetitions, we have to divide it by, because we are repeating them. It can be written wherever they are written, it's the same word letter we are writing, isn't it? So what are all the repetitions, we'll just divide it by, then into 2 factorial, which is equal to 11 factorial by 11 minus 11. So now here you cannot get a duplicate S. It is the original S itself. So if this 2 S's are written here, it can be written here also. This S's can be written here. So each and every S is being counted. So that repetition, what duplicate one, whatever is there, we are dividing it. We are removing that duplicate one. Okay. So therefore here you are getting it here in this way. 11 factorial by 11 minus 11 factorial. So this is 4 factorial into 4 factorial into 2 factorial. This can be written as 11 factorial by 0 factorial, which is 11 factorial by 4 factorial into 4 factorial into 2 factorial. So which is equal to 1 into 2 into into 10 into 9 into 8 into 7 into 6 into 5 into 4 factorial divided by 4 factorial into 4 factorial into 2 factorial. So 4 factorial is getting cancelled here. So therefore now you are having here 11 into 10 into 9 into 8 into 7 into 6 into 5 divided by 1 into 2 into 3 into 4 into 2 into 1. So here 3 2s are 2 1s are, then 4 2s are 2 2s here. So you are having here 11 into 10 into 9 into 7 into 5. So which is equal to 34650. So now here total number of letters in this. So this is the number of ways it can be written. This is the number of ways this letter Mississippi can be written. But here what is the case we have to take? I's comes together. So now here 1 2 3 4. So now 11 out of 11 you are removing this 4, which is equal to 7. So all these are i's, they are always comes together. So the remaining 1 2 3 4 5 6 7, these remaining how many ways you can arrange? Now this you can take it as 1, then this will become, the second one will become 2 3 4 5 6 7 8. So now this becomes an 8 letter word, not 11 letter word, because here all the 4 i's whatever we are getting, we are putting it together. So 4 i's taken together. Now this, wherever these i's are put, they are putting together. So here you can write this as 8 factorial, because it becomes an 8 letter word. Now you are taking this whole entity of i's as 1. So now here you are having, what are the remaining? You are having here s is repeating 4 times and p is repeating 2 times. So therefore 8 factorial by 4 factorial into 2 factorial. So which is equal to 8 into 7 into 6 into 5 into 4 factorial divided by 4 factorial into 2 factorial, 4 factorial. So this is 1 into 2, so 2 4s are. So 7 5s are 6 5s are 30 into 7 4s are 28, which is equal to 840. Now next, what is this? The first case we took. Now we'll take the second case, where we actually have to find out in this problem 4 i's not coming together only, isn't it? So now here 4 i's not come together. So from the total number of ways we are writing this 11 digit word, that is 34650. From the total number of ways the word Mississippi is arranged. The word is arranged minus 4 i's taken together. 4 i's taken together. The number of words, that is the number of words where 4 i's taken together. You can write here the number of words the 4 i's taken together. So therefore what is it? 34560 minus 840 is equal to 33810 is the answer. So now here from this, what did we learn? Main thing, it is given a letter, a word is given Mississippi, In this we have to see how many are repeated. So here letters repeated, M is repeated 1 time, I is repeated 4 times, S is repeated 4 times, and P is repeated 2 times. So how do we form this? By using permutations formula. Is total number of letters is 11, and we have how many, R is also 11 will take. We can form 11 letters, that is taking 11 at a time. How many letters can be, words can be formed? 11 letter word taking 11 at a time. How many words can be formed? We have to first find out, but we have to see how many letters are repeated over there. So we divide that by this, so that we no need to get confused with all the duplicates. We are dividing it by this. So therefore you are going to get the, by dividing you are getting 34650. Next we are finding out the 4 i's coming together. So when 4 i's comes together, wherever you put these 4 i's, you are putting them together. You are not putting a separate entity. But from the question, after finding out this, we got this answer 840. Now what is the answer which we have to find out? 4 i's not at all, they come together. They shouldn't come together. They should be separate. So the number of ways is 3. From the total number of ways the word is arranged, minus where the 4 i's taken together as one entity, the number of words formed is, we have to minus, then we'll get this answer. How many ways can the letters of the word permutations be arranged if the word starts with P and end with S and vowels are all together? Then say third one, there are always 4 letters between P and S. So here solution, what you have here in this, you are having here permutations. This is the word given to us. So now what are all the repetitions we have? We have P is repeated only 1 time, C is repeated 1 time, R is repeated 1 time, M is repeated, T is repeated 2 times. Then you are having only that is repeated 2 times. The remaining all are repeated only 1. Only T is repeated 2 times. So therefore, so total letters, so now this is 12, and now how many times this T is occurring, we have to divide by the total number of words which can be formed. So now here T is repeated 2 times. So now whatever is that word C of T is 2 times. So total now 12 letters is 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12. Here what is the first question? First one in this is starts with P and end with S. So P and S. So we are total, how many letters are there in between? So 10, isn't it? So therefore total arrangements is equal to 10 factorial, and here in this T is repeated 2 times, so this is by 2 factorial. So therefore this can be written as 10 into 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 factorial. So divided by 2 factorial means this 2 factorial will get cancelled with this. So when you are multiplying this, you are going to get it as equal to 1814400 is the answer we got. So this is the way we have to calculate this. Now the second one is, so now again consider the word permutations. So here what are all the vowels? These here you have to take vowels are together wherever they are. So now here you are having 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So now here you are having 1, 2, 3, 4, 5. So this is occupied by 1, 2, 3, 4, 5. These are arranged as, we are going to take this as one entity. So 1, now this is in the second, third, fourth, fifth, sixth, seventh and eighth. So totally 8. 8 now we are having. So total number of letters is equal to now, total number of letters is equal to 8 I'm sorry, because we are taking this is, so here n is equal to 8. So number of arrangements where we putting number of arrangements of the vowels are together is equal to 8 factorial divided by 2 factorial, because here t is repeated 2 times. So therefore this can be written as 8 into 7 into 6 into 5 into 4 into 3 into 2 factorial divided by 2 factorial. So this is equal to 56 into 30 into 12. This is the answer. Again, in this is the total number of arrangements, but we have to, because here A, E, I, O, U also can be arranged in different ways. It can be in different ways, isn't it? So in what ways can it be arranged, we have to see. It can be arranged in 5 factorial. Now the first, these 5 letters which we are having vowels can be, we have A, E, I, O, U, isn't it? Now here, so therefore A can be here, E also can be here, I also can be in the first place, O also can be here, U also can be. So therefore total number of ways the vowels can be arranged is equal to 20160 into 5 factorial. So which is equal to 20160 into 5 into 4 into 3 into 2 into 1. So 20160 into 23 is a 62 is a 120. So we are getting so many ways it can be arranged. You can find out so many words in this way where vowels can be put together. We are again taking the vowels also in different places, because it can start with A, it can start with E, it can start with I, it can be started with O, it can start with U. Then again here A can be the second letter, E can be the second letter, I can be the second letter. So in that way it be arranged in 5 into 4 into 3, that is 5 factorial ways. So 5 into 4 into 3 into 2 into 1. We are multiplying with the number of ways that taken all the 4 vowels together. Now what's the third part which we are having? It's written that there are always 4 letters between P and S. So P and S can be in different places, isn't it? So therefore here, so now here you're having permutations consists of how many letters? Permutations. T is repeated 2 times. This is 12 letters, isn't it? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now if P is over here, first place, 1, 2, 3, 4, then here it should be S should be again coming in the, these are fixed. So what is remaining? Then P can be in the second one, then this also will go next. So always the difference between P and S should be 4, because if this is in this first place, this should be always in the this place. 6th place. So if now P is coming here in this, then S will go into this. So if it is in the second one, this will go to 7th place. Then if this P is going into the 3rd place, this will go into the 8th place. Then again here, then if P is going, it is 4. So 8 is going to 9. Then P can go into the 5th place. Then it can be, S can be in this place. This is the 10th place. Now again, if P is going into the next place over here, it's coming here is 6. So this is going into the 11th one. Then again it is going in over here. P is again coming here. So you're getting here 7. This is also S. So now again S can be shifted here. So 12. So 7 factors. So total number of arrangements which you can make of this is, total cases is equal to 7 cases where P can be here. P can occupy how many places? 7. And this P can be in this position, S can be first or P can be last. So 7 ways it can be arranged, because when you're pushing it forward to go to 12th place, it can be arranged in 7 ways. So P shifting his position, you should have a difference of 4 letters in between. So this can be done in 7 ways. And then 2 ways is P can be in the place of S and S can be in the place of P. So therefore, number of arrangements of the 10 letters, the remaining 10 letters can be done in what way? 10 factorial by 2 factorial, because here T is repeated 2 times. So therefore here you can write this as 10 factorial by 2 factorial into 14. So which is equal to, this is 2 factorial, means you can write 2 ones are 2 sevens are. So 10 factorial into 7. So this will become 10 into 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1 into 7. So which is equal to 90 into 56 into 30. This is 720 into 7, which is equal to 25401,600. So therefore here you could understand this, isn't it? Because we are putting this P and S in such a way that always P and S should be having a difference of 4, and it cannot cross 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Because P can only be in the first place, it can be in the second place, third place, fourth place, fifth place, sixth place, seventh place. When it's going, you should have a difference of 4. So when suppose P is over here 1, 2, 3, 4, and then S, it cannot be more than that. So therefore it can occupy, P can occupy 7 places. In the same way, if S is also there, it can be occupying the 7 places. So this can be done in how many ways? 7 into 2 ways, because in the place of P, S can be. So therefore the number of ways is, the arrangements of 10 letters is 10 factorial divided by 2 factorial, where 2 is the number of times T is repeated, because T is only the letter which is repeated 2 times. So therefore 10 factorial by 2 factorial into 14, you are getting this as the answer. Thank you so much for listening.